Hey guys, welcome back to another lecture video for Chem 104. In this lecture video, we are going to learn how to name organic compounds that contains our functional group alcohol. And so another name for alcohol are the hydroxyl groups. And so when we're naming these organic compounds that contains an alcohol, the very first step is very similar to the first step that we did for naming alkanes, alkenes, alkynes, which is basically finding the longest carbon chain. The only difference in this scenario is that we're going to find the longest carbon chain that contains the hydroxyl group. And so looking at this example, there's two ways that we can identify a chain of carbons. One is the path that's already been circled and highlighted for us, or we can go ahead and look at this path. And so if we were to use this as our parent chain, just for argument's sake, notice that this parent chain does not contain the alcohol. And so since that does not contain the alcohol, then we know that that's not the correct carbon chain to represent the parent chain of the structure. Also, it's not the longest carbon chain. And so when you guys are trying to determine the longest carbon chain, just make sure that the alcohol or the hydroxyl group is attached directly to it. So if we're looking at this example, notice that we already have this carbon chain highlighted for us, and then somewhere on the carbon chain there is a covalent bond that links it directly to the alcohol. Okay. So this is probably our parent chain. So to determine the name of the parent chain, we're going to go ahead and count the number of carbons that there is in what I highlighted. There's 1, 2, 3, 4, 5, and 6. And so if you guys recall, if all of the bonds between the carbons are single bonds, then we're going to end our parent name with ANE. And since there's 6 carbons, the prefix that we're going to use is hex. Hex means 6 carbons, and ANE represents the single bonds that's present in that consecutive carbon chain. And so when we put them together, we'll simply get hexane. And so once you guys have that part determined, there's something else that you guys need to do. This parent chain, this parent name needs to include the alcohol. And so to include the alcohol on the name, on the parent name, what we're going to do is we're going to cross out the E, and then we're going to go ahead and just add an OL suffix. And so overall, what we get is hexanol. And so this would be the name of the parent structure that I highlighted. And so that's basically rule number 1, or step 1. Oops. And so I went ahead and I summarized it here. You're going to change the E ending of the parent alkane to the suffix OL. And so you're going from hexane to hexanol. And so when you're looking at the second step into naming these alcohols, you have to start numbering. You have to determine the numbering system for your alkane chain. And so, very similar to what we did in chapter 11, we can explore two different numbering systems. And so, I'm going to go ahead and I think it was blue and green that I used. And so, I'm going to go from left to right. I'm going to put 1, 2, 3, 4, 5, 6. So the blue is going to refer to my numbering of these carbons from left to right. Now if I go right to left, I have 1, 2, 3, 4, 5, 6. Okay. And so it turns out that when we're naming alcohols, we're going to make sure that the hydroxyl group gets the lowest number in our numbering scheme. And so what we're going to do is we're going to focus on the alcohol, the carbon that contains the alcohol. And I want you guys to notice that 3 is a lower number than 4. And so what this tells us is that the numbering system for this alkane chain, as we see it, it's not going to go from left to right. Rather, it's going to go from right to left. Okay. And once we have determined the carbon number that the alcohol is going to be on, such that it gets the lowest number, lowest value possible, we're going to communicate that to the reader. So remember that hexanol that I wrote down in the previous screen or previous slide. So hexanol, we're going to communicate to the reader where is the alcohol located. Okay. And to do that, we need to signify what carbon number the alcohol is covalently bonded to. Well, here in this case, it's covalently bonded to the third carbon, according to this specific numbering scheme. And so therefore, we're going to place that 3 in front of hex. And I'm putting a dash between them because if you recall from our last chapter, if you go from number to letter, you have to put a dash. It's part of the grammar for naming these organic compounds. Okay. And so the last thing that we're going to do is we're going to name and number our substituents. Okay. And so our substituent in this case is going to be the CH3. And so the CH3 is a methyl, right? So 1 carbon substituent. So therefore, it makes sense for us to use meth. And then the YL is to signify that it is a substituent, not a parent chain. It's not methane, it's methyl. And so if you guys are looking at the carbon and where it's bonded to, it's bonded to carbon number 5. And so we're going to go ahead and put in 5-methyl. And so since we only have 1 substituent, right? So the alcohol is not a substituent. The OH group is part of the parent name. We're simply going to take this 5-methyl and put it in front. Oops. Of the 3. So we have 5-methyl. And since we're going from a letter to a number, we need to put a dash to make sure that our grammar is correct. And so overall, the name of this alcohol is 5-methyl-3-hexanol. Okay. And so that was basically step 3, name and number the substituents and put it all together, which is what we did. And so is it possible to have alcohols that have, or is it possible to have organic compounds with 2 or more alcohols? And the answer is yes. And so if you guys have compounds with 2 or more OH groups or alcohols or hydroxyl groups, whatever you want to term them to be, because they're all synonymous, then you're going to put a prefix in front of the OL. So, for example, diol. So this di means 2 alcohols. Okay. Another name for diol, so this is just a common name, is glycol. Okay. And so you can either use diol or glycol. Now, if there are 3 hydroxyl groups, then here we have a triol. Okay. So 3 alcohols on that one particular organic compound. And so again, we need to communicate to the reader where those alcohols are located. What carbon are they covalently bonded to? And so this is the reason why we have to put in numbers in front of the parent name to describe where those 2 alcohols are located on the parent chain. And so it doesn't matter. So this is a symmetrical molecule, right? If I flip it, it's still the same thing. And so I'm just going to arbitrarily say that this is 1, this is 2. So notice that there is an alcohol attached to carbon number 1 and another alcohol that's attached to carbon number 2. And so you will say 1, 2. Remember, we have to put a comma between the numbers. So this is 1, 2 dash ethane diol. And so we have 2 alcohols. And it's on position 1 and 2. So same thing with cyclic alcohols. We'll talk more about cyclic alcohols probably a little bit later. But the main idea just stays. We have 1, 2. We have these numbers which describes the position of the alcohol. Okay. All right, so let's go ahead and go through some examples just to better understand how to piece all of these pieces together. So let's go ahead and look at the first one. So this is a condensed structure. This is a condensed structure depiction of this organic compound. So my first step is to figure out my longest consecutive chain that contains my alcohol. So here we have one, oops, let me do this in pink. 1, 2, 3, 4. Okay, so that's a pretty long chain. So let's see if there's anything longer. 1, 2, 3. Nope, that's pretty short. 1, 2, 3, 4. That works as well. And so whatever 4 carbon chain you use, it looks like 4 carbons is the maximum number of 4 carbons is the longest carbon chain in this organic molecule. So we have 1, 2, 3, 4. Let's just go ahead and work with this. And so the next step is to name the parent chain. So I know that I have 4 carbons, so that's bute, that's butane. I'm going to drop the E, and I'm going to add in all. So butanol. And so once you have the parent name, you guys are going to number the carbon such that the alcohol would get the lowest carbon number. And so I'll go ahead and go from left to right. So I have 1, 2, 3, 4. And then I'm going to go from right to left. 1, 2, 3, 4. And so if I compare both of my numbering schemes, notice that if I number it from left to right, the alcohol, actually let me change my color here. If I number it from left to right, my alcohol is going to be on carbon number 2. But if I were to number it from right to left, my alcohol would be on carbon 3. And so since 2 is less than 3, it looks like the numbering scheme going from right to left is incorrect. And the numbering scheme going from left to right is correct. And so overall, I'm going to communicate to the reader that this alcohol is on carbon number 2. And I need to put a dash to be precise with my grammar for naming organic chemistry, organic compounds. All right, so the last thing that I need to do is identify my substituents. In this case, it's going to be CH3. And so here, notice that this CH3 or this methyl group is also in carbon number 2. So I'm going to simply add in 2-methyl -2-butanol. And that would be the name of my organic compound. All right, so let's go ahead and look at the next one. First step is to determine the longest carbon chain. 1, 2, 3, nope. 1, 2, 3, 4, 5. Okay, so that's bigger than 3. 1, 2, 3, 4, 5, 6. And so it looks like 6 is going to be my longest carbon chain. And so therefore, my prefix that I'm going to use is hex to describe 6 carbons. Or hexane, since they're all single bonds. So since I have an alcohol present, I'm going to go ahead and erase the E and put in all to represent alcohol. So here I have hexanol. Now I need to figure out my numbering system. So I'm going to go from left to right. 1, 2, 3, 4, 5, 6. And then I'm going to go from right to left. 1, 2, 3, 4, 5, and 6. And so since my alcohol is located here, notice that 1 is a smaller number than 6. And so therefore my numbering system in blue is incorrect in this example. And I'm going to keep my numbering system in green. So this is telling me that the alcohol is going to be on the first carbon on the parent chain hexanol. And so now that I've written the parent correctly, I'm going to go ahead and name my substituents. And I'm going to number them as well. So notice that this methyl group is on the 3rd carbon, and this methyl group is also on the 5th carbon. And so here it looks like I have 3 methyl, and here I have 5 methyl. And so what I'm going to do is I'm going to combine both of my substituents, and since they're the same, I'm going to combine them so that I just have to represent it one time. But I have to indicate to the reader, one, its locant or its carbon number, and number 2, how many of those substituents do I have. And so I'm going to go ahead and write down 3,5 dash. I don't think I have room for this. I'm going to scoot over here. So 3,5 dash dimethyl dash 1 hexanol. Okay, and that would be the name of this organic compound. So make sure that you put a comma between your numbers and a dash between your number and your letter. All right, so let's go ahead and look at this next substance or this next example. Same idea, we're going to find our longest carbon chain that contains the alcohol. 1, 2, 3. No alcohol here, so and it's only 3 carbons. We have a whole bunch of other carbons to go through. That's probably not it. 1, 2, 3, 4, 5, 6, 7. And so it looks like 7 is my longest carbon chain. So I'm going to go ahead and write hept to represent the number 7, or heptane. And then I'm going to go ahead and remove the E, and since I have an alcohol, I'm going to write OL. So this is heptanol. And so I need to communicate to my reader where my alcohol is located on the parent chain. And so I'm going to put like a question mark here, just to remind myself that I need to fill that in. And so going from left to right, I have 1, 2, 3, 4, 5, 6, 7. If I go from right to left, I have 1, 2, 3, 4, 5, 6, 7. And so it looks like my alcohol is on the 3rd carbon. It's covalently bonded on the 3rd carbon. So I'm going to go ahead and erase this question mark and put in 3. So this is 3-heptanol. And that's going to completely describe my parent chain. All right, so the next thing that I need to do, or the last thing I need to do, is identify my substituent. In this case, it's the CH3. And notice that this substituent is going to be on carbon number 6. And so I'm simply going to write 6-methyl. And since there's no other substituents, I'm basically done. So I'm just going to go ahead and carry that over in front of the 3. So I'm going to put in 6-methyl and then dash 3-heptanol. And that would be the name of my organic compound. Okay. So hopefully after going through these 3 examples, you guys have a better understanding of how to name these alcohols by looking at these condensed structures. Okay. And so just for completion, I'm going to go ahead and erase my numbering system at the top because that was, as it turns out, that was wrong. All right, so now we've seen how to name these organic compounds in the condensed structure. What about skeletal structure? And so, same idea. we're going to identify the longest carbon chain that contains the alcohol. And so just looking at the structure, it looks like I have 1, 2, 3, 4, 5, 6. And so it looks like I have 6 carbons as my parent chain. So I'm going to go ahead and say hexane, because if you look, all of these are single bonds. Okay. And so since I have an alcohol, I'm going to erase that. I'm going to erase the E. Oh no. And I'm going to put OL. So this is hexanol. And so I need to communicate to the reader what carbon number that OH group is found. And so I'm going to number my carbons left to right, right to left. 1, 2, 3, 4, 5, 6. Okay. And 1, 2, 3, 4, 5, and 6. So remember that alcohols get priority. You want the lowest carbon number for the alcohols. You don't care about the other substituents. And so here in this case, it looks like 2 is lower than 5. And so we can go ahead and safely erase all of these numbers. So it looks like the numbering system going from right to left is the numbering system that we're going to be using to name this organic substance. All right, so the next thing that we're going to do is identify our substituents, and we're going to name their positions. And so real quick, I kind of forgot to put in 2 here. Okay. So we figured that out. And so if I were to name these substituents, this is 2-methyl. We have a 1 carbon compound, or we have a 1 carbon substituent on carbon number 2. And it looks like here we have a 5-bromo. And we have another 5-bromo. And so when we name these, we're going to go ahead and combine them together. But it looks like we have 2 different substituents. And so here we have methyl and we have bromo. And whenever you guys have 2 or more different substituents, you guys are going to organize them in alphabetical order. And so since B is before M, we're going to go ahead and write the bromines first. And so when we write the bromines, we're going to put them together. So we're going to put in 5, 5 dash dibromo. I'm going to scoot this over because I need to fit in my other substituent. And so notice that here I have 2-methyl. So 2-methyl. And to make sure that my grammar is correct for naming this organic compound, I'm going to put a dash and a dash between the letter and the number. So overall, I have a substance in which its name is 5, 5 dash dibromo dash 2-methyl dash 2 dash 2 dash methyl dash 2 dash hexanol. Okay. And so hopefully you guys kind of get the trend. There's one more example that I want to do. It involves a double bond, and you guys can apply this concept to triple bonds as well. And so here we have this organic compound, and it looks like we have a double bond present. And so we need to learn how to name alcohols with a double bond or a triple bond that's present in the longest carbon chain. And so, very similar to the first step, I have 1, 2, 3, 4, 5, 6, 7. So it looks like I have 7 carbons as my longest chain. So I'm going to go ahead and say hept. Let me do that in black. So 7 carbons. That's going to give me hept. And so notice that there is a double bond that's present on this parent chain. And so this is not going to be heptane, this is going to be heptene, right? We're using the ene ending. Now when you guys have a double bond that's present, we're still going to erase that last E, much like what we did for heptane. And then we're going to go ahead and write in all. Okay. So heptanol. Now, the thing about the fact that we have a double bond in an alcohol is that we need to communicate to the reader what carbon number these alcohols and these double bonds are found on the parent chain. And so we're going to go ahead and modify this naming just a little bit. Well, let me just go ahead and put it in here. And so to demonstrate to the reader, to inform the reader that, to inform the reader what carbon number the double bond and the alcohol is located, you typically write it in front of hept. However, since there are 2 different subjects this time, we can only put a number here to describe the position of the double bond. And so to describe the position of where that alcohol is located, what we're going to do is we're going to kind of move this guy over to the right. And then we're going to put a dash and another dash. And so in this space is going to be the number for the alcohol. And so you guys will see this in just a second. And so let's just go ahead and start numbering this. So from left to right we have 1, 2, 3, 4, 5, 6, 7. From right to left we have 1, 2, 3, 4, 5, 6, 7. Okay. And so if you guys are looking at the numbering scheme, when there's an alcohol present, this alcohol gets the priority. So we want to make sure that the alcohol has the lowest carbon number between the numbering schemes that we've made. And so since 2 is less than 6, then that means that the numbering system in blue from left to right is incorrect. And so this is telling me that on carbon number 2, I have an alcohol. And on carbon number 6, I have my double bond. And so since En represents the double bond, I'm going to communicate to the reader its position on the parent chain. And so I'm going to put 6 dash in front of hept to communicate to the reader that the double bond is on the 6th carbon. It starts on the 6th carbon. And so to communicate to the reader where the alcohol is found on the carbon on the parent chain, I'm going to put a dash and then another dash. I'm going to put -2 -all. So this number refers to the carbon number of where that alcohol is located. Okay. And so if I clean this up, I'll simply get 6-hep 10-2 -all. Okay. And so that is the name of the parent chain that contains a double bond and an alcohol. And so everything else that I didn't highlight, that's going to be, that's going to be your substituent. And so it looks like we have a methyl group on the 5th carbon. So we're just going to add 5-methyl. And so to name this compound to completion, we're just going to go ahead and write 5-methyl -6 hep 10-2 -all. Okay. And so that's an example of how to name an organic structure, organic compound that contains a double bond and an alcohol. Okay. All right. And so I guess we can go ahead and do it here. I'm just going to go ahead and modify the structure on the left so we can see it again. Let's just say that my double bond is here. And so once again, we have to find the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. So once again, we have a 7-carbon chain. And we know that the prefix I'm going to use is hep, right? And so since I have the presence of a double bond, it's going to be heptene. And what I'm going to do next is I'm going to, take out that E and add an OL. So hep10-ol. But I need to communicate to the reader what carbon number the double bond starts and what carbon number that alcohol is covalently bonded to. And so I'm going to go ahead and separate this out. And I'm going to put a dash and a dash. And so the number that I put inside the middle is going to refer to the location of where the alcohol is. And the number that I put in front of my hept is going to indicate the carbon number of where my double bond starts. And so once again, we're going to go ahead and number this left to right, right to left. 1, 2, 3, 4, 5, 6, 7. And if I go from right to left, I get 1, 2, 3, 4, 5, 6, 7. And so I want you guys to notice that the numbering system in green would produce the lowest carbon number for the alcohol. And so what I'm going to put in this space is 3. And I'm going to go ahead and erase the numbering system in blue. And so to describe the carbon number of where that double bond starts, I'm just going to go from right to left. And once I hit carbon 4, it looks like that's where my double bond starts. So I'm going to say 4 hep 10 3 all. Okay, with all the dashes and stuff. All right, so hopefully that clarifies, by doing it a second time, that clarifies how to incorporate a double bond with an alcohol. Just make sure that alcohol always gets the priority. So I've listed some more organic compounds for you guys to name. Notice that all of these are single bonds, but go ahead and practice them on your own. I believe I've already provided the answers in my PowerPoint. So if you guys go to this specific slide on my PowerPoint and look at the bottom where it says notes, open the notes or expand the notes by dragging it upwards. You guys should be able to see the answers. All right, and so in the next lecture video, we are going to discuss how to name cyclic alcohols. All right, I'll see you later.